All right, let's dive right in. If you are just starting your journey into the world of information technology, wow, you have picked an incredible time to begin. Seriously, what we're about to cover is the foundation for a truly exciting future. And hey, a huge special welcome to all the new students kicking off their studies, especially a big shout out to everyone over at Monroe University. We are so glad you're here, and we're going to walk through some of the key ideas you'll be hitting the ground running with. You know, the field you're stepping into is moving at an absolutely blistering pace. Just think about this for a second. The job you'll land in a few years, it might not even exist today. You're not just learning a subject, you're getting ready to actually invent the future. So let's officially kick things off. Section 1, your IT adventure begins. We're starting with the big picture. Why everything you're about to learn matters, well, everywhere. Seriously, just look around you. Think about a doctor's office managing all those patient records, or Amazon juggling millions of packages, or Ford using robots to build cars. What do they all have in common? Technology. IT is the backbone, the absolute central nervous system of pretty much every modern industry. The skills you're learning are what make the world tick. Okay, so we've covered the why. Let's switch gears and get into the how. Welcome to Section 2, Inside the Digital Mind. We're going to pop the hood and look at the core parts that make your devices actually work. First up, the big boss, the CPU, or Central Processing Unit. This is, for all intents and purposes, the brain of your computer. The best way to think about it is like a head chef in a super busy kitchen. Every single time you click or type or tap your screen, you're giving that chef an order. And the CPU, it gets to work, carrying out that command at an unbelievable speed. But here's the thing. Not all chefs are the same. On one hand, you've got x86 processors. Think of these as your gourmet chefs in a massive professional kitchen. They're incredibly powerful, perfect for laptops and desktops that need to do heavy lifting, but boy, do they use a lot of energy. On the other hand, you've got ARM processors. These are your brilliant food truck chefs. They're masters of efficiency, making amazing food with minimal power, which is why they are perfect for your phone or your tablet. So how does this brain actually get things done? Well, the simplest way is called serial processing. It's exactly what it sounds like. It's a to-do list. The CPU takes the first task, finishes it completely, and only then does it move on to the next one. Super simple, but not very fast. So we got a little smarter with something called pipeline processing. Picture a pizza assembly line, right? While one person is stretching the dough, another person is adding sauce to a different pizza, and the third is sprinkling cheese on yet another one. You've got multiple tasks all in different stages of completion at the very same time. It's a brilliant way computers speed things up. But the real magic, where things get really fast, is with parallel processing. This is what multi-core processors are all about. Instead of just one assembly line, you now have multiple chefs, and each one is working on a completely different dish at the same time. That dual-core or quad-core processor in your device, it's literally 2 or 4 brains working together at once. It's how you can stream music, browse the web, and run a virus scan, all without your computer breaking a sweat. Now, a brain is totally useless without memory, and your computer basically has 2 main types. First, there's your hard drive. Think of it like a giant library. It stores everything, all your photos, your apps, your school papers, safely for the long haul. Then you have RAM, which stands for Random Access Memory. This is your work desk. When you want to use an app, the computer grabs it from the library and puts it on your desk, where it's super fast and easy to access. So that leads to a really important question. What happens when your desk gets too small? Well, if you don't have enough RAM, your desk gets cluttered. To open a new program, your computer has to get up, walk back to the library, and put an old one away just to make space. That constant back and forth trip, that's what makes your computer slow down and lag. So the key takeaway is, more RAM means a bigger workspace and a much faster computer. And finally, there's ROM, or read-only memory. The easiest way to think of this is like the computer's permanent instruction manual. It's printed right into the chip. When you hit that power button, the computer reads its ROM to remember how to wake up, check that all its parts are working, and then launch its main software, like Windows or Mac OS. Okay, so we've covered the hardware, the guts of the machine. Now let's look at a really fascinating shift in how we might be creating things in the very near future. This is Section 3, Coding with a Vibe. So for the longest time, building a website meant you had to be a scriptwriter. You had to write a really detailed script, line by line, in a complex language.
But a new idea is popping up called vibe coding. With this, you stop being a scriptwriter and you start being a movie director. You don't write the code yourself, you just describe the feel, the vibe of what you want to an AI assistant. So for instance, instead of hundreds of lines of code, you could just say something like this. You describe the purpose and the feeling you're going for, and the AI just builds it. From there, you just give simple commands like, hey, make that main color blue, or add a section for customer reviews. It's a really powerful peek into the future of how we'll create things.
Okay, this is all fascinating stuff, but let's bring it all back to what really matters. You. In Section 4, we're going to talk about how you can take all this knowledge and start building an amazing tech career. And here's a huge pro tip, especially for those of you in online programs. It's so tempting to just jump right into the assignments and discussions for the week. I get it, but trust me on this. Always, always review the lecture notes first. Get a solid handle on the concepts before you try to apply them. It'll make your assignment so much easier, and you'll actually retain the information way better. Now, as you move forward in your studies, you're probably going to see two big paths pop up a lot: computer science, or CS, and management information systems, or MIS. CS is all about the deep theory. It's like learning how to design a car engine from scratch. MIS is more about the application. It's like being the expert mechanic who knows how to use that engine to solve real business problems. Whichever path you lean towards, start building your e-portfolio now. It's just a personal website that shows off your projects, your skills, your resume. It's a living, breathing showcase of what you can do, and it's way more powerful than just a piece of paper.
And that brings us to our final and honestly our most important section, because this one is all about you. We started this whole thing by saying that technology is changing ridiculously fast. And here's a pretty wild thought to wrap your head around. Roles like AI vibe director or quantum data analyst might sound like science fiction right now, but the truth is, the most exciting jobs of the next 10 years, they simply don't exist yet.
So, that leads to a very simple but really profound question. If these jobs haven't even been invented, who's going to create them?
You will. By learning these fundamentals, by staying curious, by pushing the boundaries of what's possible, you are the ones who are going to define the future of technology. Your adventure is just getting started. Welcome to the world of IT.